Okay, so let's get started here on the exercises. So I am just going to find the exercises. So we have the homepage here, and then we find the exercises. So this one, I think I should also discuss this, but before we do that, let's talk a little bit about what we actually want to study today, namely loops. So the first exercise basically just tells us to implement this square root algorithm described in the book. And I think I got the book here. I do. 2 seconds. And I found where the square root algorithm is. So what it says is that if we want to compute the square root of a number a, what we can do is a bit of a strange thing, namely we can initialize x to be anything, then we can compute everything on the right hand side, assign it to y, and then we can reassign x to be equal to y, and then repeat this procedure again and again and again, and eventually, or so the claim goes, the value of x, because we update x here all the time, x will eventually become equal to the square root of a, which is a funny thing. You can maybe convince yourself that if this procedure converge, it will actually be the square root of a, and the way you could do that is that you could set y equal to x and then solve for x in this equation. Then you would see that x equal to the square root of a is actually a solution. Of course, that's not proof that it actually works, but it is an indication that it might work. Okay, so we need to implement this. I think rather than just copy pasting the solution, which is, I think, given here somewhere. Yeah, it's given here. Rather than just copy pasting the solution, maybe it's more instructive that I talk a little bit about the while loop first, and then we can look at the solution. So let me just find Visual Studio Code, and then create a file, and call that loops, like this. Oops, I should probably have called it loops.py. So let's rename it to loops.py, like this. This is just a place where I can play around a little bit. Because what does the while loop do? So let's do a little thing here where we start by printing first, and then we print last, because this is the first line and this is the last line. And when I run this, it prints out start. Oh, start. Yeah, let's do start and end instead, actually. Okay, because now we get to the while loop. So what does the while loop do? Well, it's a little hard to explain without just showing what it looks like and then talking about it. So let's try to give an example. So if I write this, what it does is that it starts by initializing the variable x to be equal to 1. Then it checks if x is less than 3, and this will be evaluated to true the first time it's evaluated. Then what the while loop does is that it says as long as this condition is true, and it starts out by being true, it repeats everything inside the body of the loop. The indented part is called the body. Namely, it increases x to be equal to 2, and then it prints out 2. Then it reaches the end of the body, and then it jumps up here and reevaluates that condition, but the condition will now be 2 less than 3. Well, that's true, so it repeats what's inside, namely it sets x equal to 2 plus 1, so x will be equal to 3, and prints out 3. And then it repeats again, and then it says 3 less than 3, that's false. And since it's false, the loop stops, and Python just ends up on this line, and then it goes down and prints out end. So if you kept track of everything, it should print out start, 2, 3, and end. And if we increase x to 5, no, let's actually increase it. Let's start with x equal to 1, then increase that to 5. That was what I wanted to increase. Now it looks like this. So because it ends up counting to 5, like so. Okay, let's examine this in a little more detail. So let's suppose that I write false here. What happens? Well, maybe we get an indication because VS Code has already grayed out the body of the loop. And that's because VS Code correctly recognized that this will never be executed, because this condition while false will never be true. So it starts up here, it prints out start, empty line, assigns x to 1, says this is false, therefore since it's false I'm not going to do this, and then it starts on line 7, goes down and prints out n. So that's how this works. Let's try something else. So let's go back to the original idea here. Let's do x less than 10. Just print out what it does. So it ends up counting to 10, starting at 2. However, if I now write this condition, if x greater than or equal to, let's do 5, no 4, 5, break. What happens in this case? Well, it starts here, it does the same thing as before, then it checks this condition, and this condition of course starts out by being false. But when x is equal to 5, it executes this line, and this line says break. What the break keyword will do is that it'll look like it'll start by just basically looking upwards until it reaches a while loop. So it'll search through what's called the scope, namely these indented blocks, and say, okay, there's no while loop, no while loop, no. Here's a while loop, and I'm running this while loop right now. So I'm going to stop that while loop, and that means that when we reach the break point, break line, it ends up here on line 9, and then it continues. So now it will only print out x up until 5, like so. And we can put that line up here and see what happens. So what do you think will happen here? Try to reason a little about it. Will we get the same result, or will we get something different? So we'll get the same result. Because it prints out x equals to 5, and then it checks x is equal to 5, that's less than 10, and then it checks this condition, then it breaks, and then it doesn't run this condition down here. So when it reaches the break line, it goes up here. See, I'm in this while loop. I'm going to dump you right down here. I'm not going to run this stuff here. Okay, so that's the while loop. Let's try something else. So let's try to write true here and comment this out like this. So what's going to happen now? Let's try. So this condition is never going to be false, and therefore it will just keep on running like in a loop. That's why it's called a loop. So this will just basically continue until my computer breaks down. And that's not very fun. So now I'm looking for the stop button. That's a funny thing. Where's the stop button actually? Guess I should have looked for that. I don't normally... this seems a little drastic. Isn't there like a stop here somewhere? That's so strange. Well, I can't find a stop button, so we'll just do this kill. And that did it. So now it stopped. So we shouldn't do this basically, because our program will never terminate. That was one of our... That's a special kind of bug. However, we can still do this, and now it'll print up out to 5, because this condition will eventually be true and then it will terminate. So this is something that we could potentially do. Okay, so that's how the while loop works. So let's try to use that knowledge to look at our function. So we go into mathematics, and here we have the square root. And then, oh yeah, I wanted to explain this stuff down here. So let's just try to look at that really quickly. So if I change the directory to exercise 04, then let's look at this stuff here, and let's just experiment with it over in the loops file. So now I'm going to delete what I wrote here and do something else, because I'm going to print name is, and then I'll write something really odd, and you have no way of really knowing what this will do. Because when you look at this, I'm really printing out a variable. It's called underscore underscore name underscore underscore that I haven't defined yet. So in actuality, what this should do is you should give me an error. Like if I did this and then just wrote name and then gave it a couple of underscore, you can see this will give me an error. I can just run it and it'll give me an error. It's not defined. However, if I run this line, it writes out main. In other words, and let's just write it. Right? It's equal to the text string main. This is just a text string. Okay, so that's really interesting. Let's try to do something a little bit different, because let's try to write, and now I just write, let's do Bob. Now I'm just defining a variable and printing it out. But I can still run it, and it's going to write out like this, execute this print statement when I press run. No surprises there. But let's try something else. Let's try to start Python and then write import loops, it's called. So when I import this file, it executes all the lines in the file. And that's actually something we've seen before. So, but this is just using an import statement. So it prints out this variable. So that might give us a small idea. Let's do this. And since I'm in the interpreter, I actually need to restart the interpreter before it recognizes the changes to my file. So that's a little bit annoying, but I'll just restart it like this. And now let's try to import it. So remember before when I ran this script, name was equal to main. So it should still be equal to main here, right? It's not. It's equal to the name of the file. So in other words, this special variable is one of the only mechanisms I can actually use to check if a script is being imported or it's being run by pressing run up here. In other words, if I have something that I only want to run when I press run, what I can do is that I can write is this variable name equal to name, and then I can write print the run button is pressed, and otherwise I can say print the script is imported, and then I can say loops starting like this. And we can actually check that this works. Let me just start by terminating this. When I press the run button, it says the run button is pressed. Whereas if I import it, it says the script is being imported. Okay, so why is this convenient? It's convenient because we often want to sort of have informal tests of our scripts that only runs when we press the run button on the script and doesn't run when we import the script as we do here. That's especially true when we do testing and so on. In that case, we often want to import our script and make use of it. So that's why it's very, very common in Python to have these checks near the bottom of the file, and now you basically know how and why it works. Okay, let's comment out this function and then look at what happens when we want to compute the square root of 2 using the algorithm that we have in the book. So it should be implemented as this function. It's given a variable a, and then it needs to compute the square root. So how can we do that? Well, let me just find here. So we want to repeat this line again and again, starting with a given value of x and given this constant a until some condition is met that we'll discuss in a second. So how can we do that? Well, we first need to give x an initial value, and that can actually be anything. So I'm just going to give it the value 3. 3 is a nice number. Then what I want to do is that I want to repeat the line that was given in the assignment. And I'm probably going to get this a little bit wrong, but I think it was this. Yeah, that was the magical equation that just happens to work for the square root. Okay, so we want to repeat this a number of times. So let's start by repeating it forever, like this. Then we repeat this line, and then we had to say that x was equal to y, because we want to update y, and then we want to repeat the procedure but with x replaced by y. So that's why I'm having this line down here. And then, of course, if I press run now, it's just going to run until forever. So when should this stop? The algorithm has a hint. So it says that when the difference between x and y is less than some very, very small constant given here, the algorithm should stop. And it stops by stopping the loop, and we can do that with break. So let's try to check that. Let's do that like this. Okay, one last thing. I'm using math.apps. So what does that do? Let's just see what it does. So math.apps, oopsie doopsie. No, wait a second, so it's not in the apps module. Let's see, apps. It's just outside here, sorry. See, sometimes I also make mistake. I was sure that the apps function was a part of the math module, but it's not. But let's examine what it does. So we can see that when we call it with a number 3, it just gives 3. When we call it with 0, it gives 0. Decimal number is decimal number. But when we call it with negative numbers, it just returns a positive number. In other words, when we compute this apps, it computes the absolute, like the difference, but always with a positive sign between the two numbers. So we check if the difference is less than this value here, and in that case we stop the algorithm. So I think this should work. So let's try to print out some stuff along the way. So now I'm printing out x, and I'm printing out y, like this. And then let's also print out difference. And the difference we can compute like this. And then let's see what happens. Well, what's going to happen? Actually, I know what happened. There's a problem with this code, so let's just run it and see. Whoopsie doopsie. I need to exit the Python interpreter when I click run. So it says the square root is none. It prints out a lot of stuff, but it doesn't seem to do quite what we hoped it would do. So why is that? Well, it's because I'm missing a return statement. So I need to have a return here in the bottom of the function. And now it computes the square root. And this is actually very, very close to being the square root of 2. So we can maybe check that with a number that we are a little more familiar with, like 9. And it works. So it also seems quite interestingly that this is independent of how we initialize x, which is an interesting behavior of the algorithm. Could I simplify this code a little bit? So actually I could, because this return statement, I can just do the return here. And now instead of breaking, it's going to hit the return statement. And when it hits the return statement, the whole function returns. So instead of like going up here and stopping the while loop and then seeing what happens afterwards, right now I'm just saying return x, and then the function itself will plop out x, which will have the value we want it to have. And that's why I'll get like a 3 in this case. So we can see that this works, and I can remove this down here. So now it's equal to 3. So that's how we can implement this function. And I think I'll stop here, and then I'll only talk about the debugger in the next video, because this one has already become quite long. So thanks for your attention.